So hi everyone, in this video, we are going to discuss about pointers and multidimensional na arrays. So basically, we are going to use the pointer notation to manipulate the elements of a multidimensional na array. So as discussed in the previous lecture, just as pointers can point to elements of one-dimensional na array, it is also possible for pointers to point to elements of multi-dimensional arrays. So revisiting its concept, the simplest na multi-dimensional array is an array with two na dimensions. It has a row as well as a column. And how can we access each element? So we can access each element by using the two subscripts, where the first na subscript represents the row and the second na subscript represents the column number. So we visualize here an array with two dimensions. So the name of the array is A, and it has 3 rows and 4 columns. And note that both of the subscripts begin with 0. So if we want to access the element in row 2 and the column 3, we simply have to write A of 2 and then 3, where 2 refers to the row number 2 and 3 refers to the column number 3. So in a generalized form, so it is of the form A of I and J, where I refers to the row and J refers to the column. So the elements of a 2D array can also be accessed with the help of a pointer notation. So if this is how we access the elements of an array using the ordinary, say, array notation, this, on the other hand, is the equivalent pointer notation. So we have the A plus I. A refers to the name of the array, plus I, which is the row number, and then enclose it in an asterisk. So this gives us the whole na row. So note that a 2D na array is just an array of arrays. So each element of the array is also an array. Okay, so the A plus I, that this will give us the whole na row. Okay, and if we want to get the element, the column, the column number, we simply have to add the J, which refers to the column number, and then enclose the whole expression in an asterisk. Okay, so let's see how this expression was derived. So let us quickly go back here and with this example, and assuming that we have this array A with, as you can see, 3 rows and then the 4 columns. And these are the elements of the array. So 3 arrays with 4 elements each. Okay, and this is how we can visualize it. So the first row contains 1, 2, 3, 4. Second row contains 5, 6, 7, 8. And the third row contains 9, 10, 11, and 12. Okay, and do you remember how the 2D arrays are stored into the memory? So the C stores the 2D arrays in a row major na order. Since memory in a computer is organized linearly, it is not possible to store the 2D arrays in rows as well as columns. So the concept of rows and columns are only theoretical. So we visualize it like that, so it will be easier to understand the concept of arrays. But in reality, a 2D na array is stored in a row major na order. That means that the rows are placed next to each other. And this is how we can visualize it. So this is the first na row, followed by the second na row, and the third na row. Okay, so assuming that the first element of the array is at address 500, and the size of type int is 4 bytes, then the elements of the array will get this following na allocated memory locations. So the element in row 0, let's say, is 5,000, right? So since allocated for integer is 4 bytes, let's say, so the next na address would be 5,004, and the next na address would be 5,008, and so on. Okay, so this is the element in row 0 and column 0. And this one is the first na element in row 1. And this one, on the other hand, is the first na element on row 2. Okay? So the name of the array, as you know, is a constant na pointer that points to the address of the first element of row 1 and contains the address 5000. So we have the name of the array, and it's a constant pointer that points to the address of the first na element. So in this case, the address of the first element is assuming in 5000. So A will be containing 5000. Okay? And we have the A, which points to the first element of the row 1. And if we perform the arithmetic, if you remember, it does not mean that we are going to add +1 and this will result to 5001. Rather, it would be pointing to the address of the second na element, and the difference would be 4 bytes. Okay, so that would be A plus 1 times the scale factor, in which the scale factor would be the number of bytes. So in this case, it is 4. Okay, and if we again add A plus 2, so this will give us the address of the first element of row 3. Okay, and now in general, given an array, 2D array A, we can write A plus A to be pointing to the ith na 1D na array. So the A plus I will point to the array. And to access the values, we reference it using the reference na operator. So we simply enclose this expression A plus I with the reference operator or the asterisk. Okay, so the asterisk A plus I is basically just equivalent to A of I. So the address or the value in A is equivalent to A of 0. So that will give us the row 0. And the asterisk followed by A plus 1, that is equivalent to A of 1. And this will give us the first na row. And the asterisk of A plus 2 is just equivalent to A of 2. And this will give us the row 2. So now, what if we want to access the individual element of the 2D array? So in the previous slide, what we are getting here is only the row, the whole row. What if we want to get the element, a certain element in that row? So to access the individual elements, we use this pointer notation. So simply using this, the A plus I, and then enclose in parentheses, asterisk plus J will give us the address. So this, on the other hand, will give us the value. So as you can see here, can you see this whole expression? That is being enclosed in parentheses and the reference na operator, which means that we basically want the value in which this expression is giving, or in which this address is storing. Okay, so if we have this expression, so this is equivalent to A of I and J, which accesses the individual elements. Okay, so if we want to access this element in row 0 and column 0, so we simply have to use this expression. Okay, and this is the only pattern. So you have the 0, which refers to the row number, and this one refers to the column number. Okay, and if we want to access, on the other hand, the element in row 2 and column 3, so we simply have to make use of this. The element in A plus 2, or this basically will give us the row 2 plus the 3, or the column number 3. So the A plus 2, this will give us here. This will give us is the address in here, and then plus 3, so that would be 1, and then 2, and then 3, and then the value in here, so this will give us the 12 na number. Okay, so suppose we are in a plus 1, so let's understand the logic behind here. So suppose we are in a plus 1, so that means that we are referring to the first element in row 1, and we want to access this element. Okay, so it is just 2 addresses away. So as you can see, 1 and then 2. So this is just 2 addresses away from the first na element of the second na row. So we simply have to add 2. Okay. So for this example, we will be using the concepts that we have learned in this lecture to build a text-based snake and ladder na program. So this is the game na mechanics. So there will be 2 players, and the 2 players will be taking turns to roll the dice and move the counter forward the number of spaces shown on the dice. So if the counter lands at the bottom of the ladder, then you can move up to the top of the ladder. If the counter lands on the head of a snake, then you must slide down to the bottom of the snake. And the first player to get to 100 or beyond 100 is the winner. So if we go back here, so each player will be rolling a dice. So for example, I am player 1 and I rolled the dice. And my dice went to 4, is equal to 4. So I will move 4 steps. And since this is in the bottom of the ladder, I can quickly go up to 56. Okay, so assuming that player 2 is in 30. Okay, and then player 2 is in 30. Or let's say me, I am on 30. And then I roll the dice, and then it gave me 2. So I have to move 2 steps. So there is a snake here. So I will be moving to the bottom. And this will give, I will be moving to 10. Okay, so yeah. We will be applying the concepts of the array of pointers and also returning pointers from functions and multidimensional arrays and pointers. So let us begin. So these are the functions that we are going to write. So we have the generate board function. So as you can see, we have a pointer na notation here. That means that this function will be returning a pointer, and this will be used to display a 10 by 10 board. And we are going to list the ladders in the board with the void print ladders function. That's, since this is in void, so it will not return anything. And then to list down the snakes in the board, we have the print snake function. And then to display the board, so we have the print board, and it accepts this pointer containing a 2-dimensional array in short. And then in roll dice, so that this will give us a random number from 1 to 6. And to check for snake or ladder na method that accepts a position na argument. So this checks checks if a user's position lands on a snake or a ladder. And the move player, on the other hand, this moves the position of a player based on the result of the rolled dice. So note that this is just an example, and the functions will depend on your needs and how you organize your code. So the implementation will be totally dependent on how you want to implement it. Okay, so you can have as many functions in your program if you want. So we will be using these ladders in order to headers pala to use functions to produce random numbers. And then the std bool. And then the other libraries that we have, the stdio, stdlib, and then the time. So shown also are the function prototypes in the code. So I have already shown you this. And we are going to generate a 10 by 10 na board. So we have this generate board na function of type na pointer. And as you know, we have to declare this array as a static variable. So since it's not a good idea to return this outside of a function, so we declare it as a static. So we're basically telling this is still local to the generate board function. So static int board 10 by 10, and contains the um, this contains the board that we have. Okay, the board from 1 to 100, and we return the board. And since we are returning the array board, we have defined it as static. And note that the function name is preceded with a pointer and operator, as you can see, which indicates that we are returning a pointer. So how is this how is this possible? You know, right, that we cannot return an array. But if we are, and this is only possible if we return its address instead. Okay, the address of the array instead. And now we let the user know the snakes and ladders in the board based on the figures below. So we have how many snakes? 1, 2, 3, 4, 5, and 6. So if you land in 54, then you will have to go back to 88, say, and so on and so forth. No. If you land in 54, you have to climb up to 88. So this is in the print ladders. And we have total of 6 ladders. And for the snake, we also have 6 snakes here. So yeah, let's say if you land in 79, then you will have to go down to 41. Now the print board expects the array of pointers. So we have specified here that it receives an array of pointers, and the name of the pointer is board. Okay, and this simply prints the 10 by 10 na board, this function, this print board na function. So we are going to iterate on the array that was passed to print board. Okay, and we are using this pointer notation. So board plus I, that refers to the row, and then plus J, which refers to the um, column number. Right, and we also print the ladders, and as you can see, it prints here the ladders and the new line. So, and then we print the snake. So it simply prints all of the information that may be relevant or needed by the player. And this function, on the other hand, is called every time a player has to roll the dice. So we have the roll dice function. And this returns a number, random number between 1 to 6. And we are going to create a function to simulate the snake and the ladder. So for instance, if a user lands to position 88 here, so it returns 54. Okay, so it receives the position. So yeah. And then the move player receives the current position of the player pause, and then returns the new position of the player after rolling the dice. Right, so this is a part where we ask the player to roll the dice. So we call the roll dice function. And the roll dice will, as you remember, will give us a random number between 1 to 6, and then that will be saved in the dice. And that will be added to the current position of the player. Now, that will be the new position. And that in that new position, we are going to check if there is a snake or a ladder. Okay? Yeah. And then it simply returns the position, the final position of the player. And next is we ask the user to roll the dice. So, ito pala yung explanation. And then we now compute for the new position of the player. We simply add the result of the rolled dice to the current position of the player. And then we now check if there's a snake or ladder in the new position. So if there's a ladder in the new position, then the position of the player will have to go up and will go down if there's a snake. And we then return this result to the return this result to the calling function. Okay, and note that we have this board which is 10 by 10 na array of pointers. And we have all specified here. And then we call the generate board na function which will give us which will return the address of the static na array of size 10 by 10 that we have created. And then we print the board. Okay, and the players will keep on taking turn while no player still reaches 100. As you can see here, while player 1 is not yet on 100 or player 2 is not yet on 100, then this will keep on looping. So the game will continue. Okay? Yeah, so that's all for this topic.